Hi, welcome to this lesson on calculus, sketching cubic functions. Let's have a look at question 5. We're given a function f of x in its factorized form, so 3 factors here, and there's also a negative sign outside here. So our a value is -1 here, which is less than 0, so the graph should have a decreasing, increasing, and then decreasing shape. And we can see that is the case in this given function. We're also given those 3 factors, so we know the turning points, or not turning points, the x-intercepts. So at x equals -2, which is probably here at B, that is a x-intercept. At x equals 1, which is probably E based on this graph, is a x-intercept. And G looks like the last x-intercept, which is 6, 0. Then it has turning points at C and F. Based on this graph, it looks like the x-coordinate for the turning point will be negative, okay, because it's on the left of the x-axis. And then F looks like it'll have a positive. Now, you can't just make the assumption because of quadratic functions that the turning point is directly in between the two intercepts. That's not true in general. Okay, so that's not an assumption we can just make. So we'll have to find the turning points the calculus method way. So finding the first derivative and setting it equals to 0. Okay, and we also have the line AF is parallel, okay, to the x-axis. Okay. All right, they want to determine the length of OB. So O is from the origin to the point B. We know that B is an x-intercept, -2, 0. So the distance from O to B, the length is 2 units. All right. Then we want the length of OE. We saw that E was the coordinate 1, 0, and O is the origin. So again, the length or the distance is 1 unit. Next, they want the length of EG. So we saw that E, again, was the coordinate 1, 0, and G was the other x-intercept coordinate. It was 6, 0. So the distance, the length between these 2 points on the x-axis is 5 units. Okay, so that's the length there. The length of OD. Okay, so D now here, this is the y-intercept. So that's when we plug x equals 0, so the origin. So let's go find that. So if I put f of 0, I'm going to have negative 0 plus 2 is 2. 0 minus 1 is -1. 0 minus 6 is -6. So I have -2 times, -1 times -6 is +6. So I have 2 times 6 is 12, times -1 is -12, which makes sense based on the location of that intercept on the graph. Okay, so from the origin, 0, 0, down to that point there, the length of OD is 12 units. Awesome. Determine the coordinates of C and F. Okay, so again, C and F were given as turning points. So what I'm going to do is I'm going to expand that function out. So negative, I'm first going to expand these two out. So it's going to be negative x squared. Then it's going to be negative x plus 2x, leaving you with positive 1x left over. And then -2. And then that's all times x minus 6. Okay, so what I'm going to do is I'll leave this negative sign out for the last. So I'm going to first expand out these terms here. So I'm going to get x cubed minus 6x squared for the first term. Then I'm going to have plus x squared minus 6x for the second term expanded. And then minus 2x plus 12 for the last term expanded. So I have negative, let's clean up inside the brackets. I have an x cubed, negative 6x plus x squared. So negative 6x squared plus x squared, that's -5x squared. Then I have negative 6x minus 2x, that's -8x, plus 12. And then expanding the negative out, so it's negative x cubed plus 5x squared plus 8x minus 12. So we want the turning point, so we need to find the first derivative. So by the power rule, negative 3x squared plus 10x plus 8. And for turning points, we want the first derivative equals to 0. So I'm going to go ahead and use the quadratic formula here to find those x values. So that's x equals minus b plus or minus the square root of the discriminant term, b squared minus 4ac, all over 2a. Okay, so therefore x equals, so b is 10, so it's -10 plus or minus square root 10 squared minus 4, a is -3, and c is +8. Okay, so just be careful with your signs, and that's divided by 2 times -3. Okay, so therefore x equals, so let's get our calculator out. So I'm going to do the positive one first. Negative 10 plus the square root of 10 squared is 100 minus 4 times negative 3 times positive 8 all over negative 6. So I get x equals negative 2/3, or x equals, so now I'm just going to change that to a plus on the top. So let's do that. And we get, we had plus already, so we're going to do negative, and then you're going to get x equals 4. Okay, so x equals 4, that's positive. That looks like it'll be the f coordinates for the x position there. And then c, negative 2/3, that looks accurate, so negative 2/3. Okay, so we still need to find the y values. So what I'm going to do is, on my calculator, I'm going to push 4 equals and put that to store in A. And then I'm going to put negative 2 divided by 3. That's going to go shift store B. Okay, so now I'm going to put it, I could either put it in the original function we're given or that expanded function. So I'm just going to go ahead and put it in the function we're given, negative. So alpha A plus 2, then another bracket, alpha A minus 1, and then alpha A minus 6. So this is when x equals 4, 36. And that makes sense because you can see it's above the x-axis, so it's on the positive y-axis side. Okay, and then same thing here, instead of A's, I'm going to put B's for negative 2/3. Okay, so putting all that together, I get negative 400 over 27. Okay, and that's going to give you approximately, let's just see what that is on our calculator. That's about negative 14.81. Okay, but I like to leave it in its exact fractional form. So those would be the two coordinates for C and F. Then we want the length of AF. Okay, so F we just found out was 436. Okay. Now, we don't know the x position of A, but it looks like it's just next to B, and B was that coordinate, negative 2, 0. So it's probably going to be something less than negative 2, like maybe negative 2.5, negative 3, negative 4, we don't know yet. But we do know the y value because of this property here, that it's parallel to the x-axis. So because it's parallel here, this y value here that it shares with it is the same, so 36. So we know the y value is 36. So how do we find the x value? Well, we've got that original function, f of x. Okay? And we know what the y value is. It's 36. So let's recall your f of x. When I expanded that thing out, what did we get? Negative x cubed plus 5x squared. Okay, so let's come up here. Plus 8x minus 12. Now, that must equal what? 36 as a y value, because we're looking for the x value that gives us a y value of 36. Okay, but we already know that another x value does that, 4. Okay, so when we put x equals 4 into this, we know that we get 36. So how can that help us? Well, we could try and factorize this entire original expression, but we need to bring that 36 over to the left-hand side. Or better yet, I'm going to take all the terms on the left and move them to the right, so I can get a positive x cubed. So I'll get x cubed minus 5x squared minus 8x, then bringing over negative 12, so that's plus 12, so that's plus 48. Because of that, 36 equals 0. So now look at this. We have a new cubic function, okay? And we know that we are looking for another x value that when we put it in here now will give us 0. Okay, but I know x equals 4 will probably work here because it's lying parallel here. So if I put x equals 4 here in this first function, we should get 36, and 36 is equal to 36. So that's a true statement, a true equation. So it should still hold true here when we do this manipulation. So let's check. If I put 4 here, I'm going to get 4 cubed minus 5 times 4 squared minus 8 times 4 plus 48. Okay, 4 cubed, that's 64. 4 squared is 16. 5 16s are how many? That's 50 plus that's minus 80. Okay, 8 times 4 is 32 plus 48. So let's see what we have together. 64 plus 48, that's going to give you 112. And then what's 80 and 32? So that's 80, 90, 100. I think that's 112 as well. Let's just double check. Negative 80 minus 32. Yeah, negative 112. Awesome. So that gives us 0. So x equals 4 gives us that. So therefore x minus 4 is a factor. Okay, so that was the important thing. That's why 4 helped us there, because immediately it gave us an idea of what the factors would be of this new one here. So let's rewrite this one in a different color, so we know this is the one that we are actually referencing now. Okay, so it's over here. Okay, so let's try and factorize that. So it's going to be x minus 4, we know is one of the factors. Then to get x cubed, I need x squared, and to get positive 48, I need negative, how much here? Tens and then 2. So I think 12, yeah, because that's going to give you positive 48. Awesome. Then plus bx. So again, I'm going to do the logical inspection methodology. So on the left-hand side, I have negative 5x squared as my x squared term. On the right-hand side, I'm going to have x times bx as bx squared. And then negative 4 times x squared is negative 4x squared. So bringing over the negative 4x squared, I get negative x squared equals bx squared. Therefore, b is negative 1. Okay, so this factorizes further to x minus 4 times x squared minus x minus 12. Okay, so it's going to be x minus 4 into, so now factors of 12, they'll give you a difference of 1. I think that's positive 4 and minus 3. Or rather negative 4 and positive 3, because we want a negative 1x. So I'll say x times 4 times x plus 3. So if I expand that out, I should get x squared minus x minus 12. Okay, so there's a repeated factor here, x minus 4 all squared times x plus 3. Okay, so what were we doing here this whole time? Notice that this new cubic function that I was factorizing is not the original function f of x. It was this new one here that we created by making the old function f of x equals to 36. Because I want the x values that give me that. There should be 2 of them. X equals 4, which we saw from our factorization, that's correct. And then another one here, negative 3. Okay, because that'll be negative 3 here. Okay, so there is the x coordinate for A, negative 3 and 36. And we saw that that had to be true because it was just a bit to the left of negative 2. So that makes sense from our graph. Lastly, the length of AF is from negative 3 to positive 4. So that is 7 units long. Awesome. Okay, and then lastly, we want the equation of the tangent line at the point E. So at the point E, okay, it almost looks like the tangent line looks something like that. Okay, or actually maybe slightly above it. Okay, let's check. Okay, so at the point E, this was an x-intercept and it had a coordinate of 1, 0. Okay, so remember the tangent line has the form y equals mx plus c, where m is the gradient of the tangent line, so that's the derivative at that point 1. So remembering that the derivative function f of x, we worked that out previously, and it was given by negative 3x squared plus 10x. What was the last one? Plus 8. So if we plug that in at 1, that's going to be negative 3 times 1 squared is negative 3, plus 10 times 1 plus 8. That's going to be 18 minus 3, which is 15. And that makes sense. It's got a positive gradient. It's increasing. So we have y equals 15x plus c. And then lastly, we substitute the point of contact, which is 1, 0. So when y is 0, x is 1 plus c. So if I take over the 15, I get c equals negative 15, which makes sense. It goes all the way down. It cuts there. Okay, so therefore, the equation of the tangent line at the point E is given by 15x minus 15. All right, so that's how we would do this type of question. I'll see you in the next one.